Yeah. So you want me to set up recording locally?
It's your audio, but it's okay if you don't.
Okay.
We record Discord separate from game audio, so it should be okay.
Yeah, it's okay if you don't want to. We'll have it anyway. So.
Oh, wait, no, I need OBS, not that DLC.
Right, stream is ready whenever y'all are ready to start. I'll step off the stage for now.
Yeah, we'll be getting started very shortly here. I think Uni, when you rejoin, I'll just TP you back. How's everyone enjoying Summit so far? We're about to get started here. Sorry for the delays related to this panel, but I know World Gen's been a highly coveted topic. I like World Gen. Summit sort of neat, maybe. Let's have one more announcement. Cool. I know we're in our second week now. It feels like Summit's going a bit faster than we might have expected, but there's still plenty of Summit available.
Yeah, there's so much stuff going on, and it's so high quality. I just love it. No. Like, outside of World Gen, the last time I touched MC Functions was like 4 years ago, and it's not even the same game anymore.
Yeah. Definitely changed a ton. That's awesome. I know a lot of people in the Smith ecosystem, they got into map making and data packing through Summit last time, and we have some booth vendors that joined us after, exploring last time. Definitely do upload your data packs to Smith. We'll be making it easier and releasing new features hopefully later this year to make it more exciting for everyone. We'll just be getting started very soon, just waiting for Uni to hop on stage.
Yeah,
Smith does not have custom map support right now.
Right. And I'm waiting on Mojang's the API to let me authenticate.
Classic.
Please don't be down.
I do not have a favorite Mandelbrot set. Maybe all of them. Can we use simple voice chat for the event? Or do we need to join YouTube stream? We will have voice chat on if you can hear me in voice chat. I just can't hear you in voice chat.
No.
And Uni should have that set up as well. So. Sorry about the delay, folks. We had some tech issues that are being resolved.
Yeah.
Yeah, Katter, I didn't realize that either, that this was JSON. I thought it was something else. It's crazy.
Right. Right. Is my mic quality better?
Yes, but you're a bit close to your mic, I think.
Um,
But I would say you're pretty solid.
mm,
Are you still able to join the game, Uni?
yeah. Right. Where am I in the queue? Not in the queue. Good.
You're in the queue.
Oh, I'm second in the queue. All right.
I can just move you directly here.
Okay.
Oh, there we go. And we're back. You may need to reset up your scale. I'm sure the
Okay.
resource packs are loading.
Yeah. There. One thing about the server is I've never had resource packs reload. I've also never seen the progress bar go backwards before summit. But
Yeah, these are some pretty hefty loading times.
but this is very amusing to watch. All right. Set up my scale again. That's spotlight attribute.
Uni, I think, are you muted in game?
The the. All right, I'm unmuted in game.
Oh, there we go.
Great.
Cool.
Can you hear me through in game?
Yeah, I think everyone can.
Okay.
Okay, cool. Awesome. Sorry for the delay, everyone. Let's go ahead and get this panel started. This is Intermediate to Advanced Density Functions by Uni. And whenever you're ready, Uni, go ahead and take it away.
All right. So, quick disclaimer or like quick introduction to what we're getting into. Density functions are the terrain system of Minecraft, and basically, there's been no, to my knowledge, attempt at a resource of uh, that caters to more than an advanced understanding. And this isn't because this isn't due to any real fault other than density functions until very recently have been just extremely opaque to get anything done in. So, for example, here we have the Mandelbrot set. And beside it, we have the thousands of braces in one file that I used to make this. And we have a don't do this. We don't need to do this. So a world gen developer. Yes, this is a JSON file I wrote. It broke every single JSON parser I put it in except Minecraft with the stack increased. So I had to use a stream processor that didn't look at the whole thing to be able to format it in order to get it to look like that. So, a developer at Mojang named Geggy has been doing a lot of work to make the density function system nicer to use. And so I've had to restructure this to focus a bit on hacky details we don't really need to do. Into higher level structures. So, how do I toggle screen? Oh, is it shift click? Oh, how do I actually right click? It opens the right click screen specifically. Okay. All right. What was the loot give a command again? Oh, thank you. All right. So, yeah, this is what I um yeah, this is the introduction I was going over. So, Okay, so right, okay, yeah. Oh, yeah, how quickly? Okay, yep. So we're going to, wait, did it stop working? Okay. So we're gonna go over, to start with, some of the most, like, underrated and most important density functions that I see, a lot of people don't recognize the full power of. So the 3 most important are shifted noise, splines, and gradient. Shifted noise specifically as a superset of noise because it's the heart of where all density functions get their expressive power. It is also the ability to shift the noise in the x and z coordinate has led to like basically every single innovation in density functions ever has come through shifting noise in some way. It is just that important, and we will go into it will be the basis of many of the examples at the end. Lines are Lines are a superset of all the arithmetic you can do, and perhaps the most convenient form you could ask for. And splines are where you can like let your creativity really flow, like where you can fine tune and tweak how something looks, not like mathematical expression of what it is, but like how it looks and how you want everything proportioned. The splines are really where the fine creativity comes in density functions. And they avoid a flaw in the density function system that we'll get to later. That means that you should use them basically everywhere you can. And lastly, gradients. Gradients weren't always this powerful, but they've always been necessary. So prior to the latest snapshot, we had Y-clamped gradients. And what this was is it gave you the Y value in a way such that you could cap off bedrock or on the bottom of the world or air on the top, or you could also project a noise that's 2D to be a height map. Both are absolutely fundamental woven, but now we have really powerful X and Z gradients. Those let us make cells. So as we go away, shifted noise, uh, yeah, it's really hard to broach the topic of shifted noise because it really is this central. But the wait, uh, just know that it's going to be like implicit in basically everything I say that we're using shifted noise in some way. Uh, and we'll circle back to that since I have specific examples. Lines are so what a spline is you provide a list of points and slopes between them, and it draws a cubic equation between each point. That's 1D spline. You can nest them inside each other, and what you get is a smooth flowing between spline points. Now, what vanilla primarily uses for them is it keeps the slope always 0. This is very good for keeping things simple to generate while still working and creating lots of flat areas for people to build on. So, one other very, very useful point of splines is sometimes we don't have functions. Like, we do not have sine, we do not have cosine. Uh, so we want to be able to use sine and cosine because trig is cool. Or we want to be able to use some other one-off function, but we just don't have the primitives for it. We can use splines to make an approximation of that function for our uses. And then it's as if we had that function just for writing like 10, 20 bits of code. May want to look. Okay. Yeah. Open that. So, mm, oh, it's not working. So gradients, it's another fundamental building block, but they're easier to talk about. Basically, anytime you're using a gradient, you're turning a height map, a y gradient, a height map, into terrain, which is very useful. And if you're using X or Z, you're usually making some kind of cells or repeating pattern. Within each cell, you're randomizing something. So it's very useful. It's a more technological thing, but we've had for the interest of people who have to port to older versions, you'll find that X and Z gradients, if you use them, are the hardest to polyfill. And so there's two methods that you can do, and I have example data packs distributed for both of them. And you can either, it's the fact that when you scale a noise out really closely, it's effectively a flat plane. And by sampling along it in such a way that you're only pulling the X difference, eventually you can get a flat line with the form y equals AXB, and you can solve for X. And this is a very old technique. It was used in Peak 3 or 4 years ago, but Peak was a slow implementation due to a compiler issue I will get to later. The best way to implement it is use whatever form of inversion you have to do division. Whether it's a spline, approximate it, or a later added invert density function. It depends on what you have access to. If for technical purposes, or you really need a specific repeating pattern, another option is to use the fact that the Farlands patch Mojang implemented is cyclic in the way that it wraps you back into range and out of range. What you can actually do is for a very high noise value, it cycles between two values, since that's the only bit left that it can access. And those two values, they, when input into the noise, shouldn't affect it because it's modular, but they actually give different results due to precision loss for the larger values. So you can use the Farlands patch to create effectively stripes of noise, and you can compose those stripes into as wide density or as wide stripes as you need. And I've used Mesode for this. It's the most approachable way to get visuals because the VS Code extension is currently working. So yeah, I have used the Farlands patch method professionally in Stoneblock 4, where I wanted to make sure that the rings were perfectly round in the same size. And yeah, we don't have to do this anymore, thank goodness. I would like to call out that depending on your version, you may be able to use litho-stitched or more density functions, the mod dependency, to get these. Just try not to do this because it's hell. But if you absolutely must, there are two methods and they do work. So, something else you should keep in mind is if you are on an older version and you don't have the new round and truncate introduced in the snapshot, you can add a big value and subtract it from a number to round it. You can also round by multiplying and dividing a big number such that you hit near 0, but that's more clunky. It's easier to do with splines, but still pretty clunky. Yeah, newer versions have introduced exponentiation. And exponentiation is really powerful if you need it. Because there's a lot of things where it's just not necessary, but whenever you have to do there's a very specific thing that I really love exponentiation for. It's just normalizing vectors, and it's a higher level concept, but it allows me to take a direction to get from the noise and scale it such that the direction's magnitude is 1, which basically normalizes it such that it is just an angle, which is exceedingly useful for many things later on. So exponentiation gets a shout out for being able to do the inverse square root, which is it's why, if you ever heard of the fast inverse square root algorithm, why that was important is like inverse square root is one of the most important functions you can do in mathematical rendering or similar sense. And so having this in vanilla now is really nice. Thank you, Gaggy. And find top surface. Find top surface is an underrated density function because you can take the result of find top surface and feed it back into the function you were searching for the surface of. And what this gets you is it lets you loop until a value matches a certain condition. And this is very nice. A very good example I found for this is region noise. So we take a noise and we scale up through it. We search up through it until we find top surface search down. We search down through it until we find the largest point that's greater than a set constant. And this will naturally create these regions where we will have the top region be mostly undisturbed, and then the other regions will look like they're layered under it. Kind of like the ground covered in multicolored petals. And that could be a really cool effect. Just in general, taking some time to play around with find top surface. It's a newer density function, so if you're stuck on old versions, you won't have it. But it's a really fun and approachable way to do some cool effects that would be really annoying or possibly in performance otherwise. So we're gonna get into the 3 most common pitfalls I see in advanced projects. And these are actually very technical in nature. It's not like you can go years without figuring out that any of these are a thing. I don't think until I did a ton of code analysis that compilation lag as a concept was even known about in any wide sense, other than just the compiler is buggy sometimes. So, yeah. Caching. The caching structure in Minecraft is just very volatile. It is meant to be used in exactly one way. And if you do not use it this one way, you will hit like hundreds of times worth performance for seemingly no reason. It is genuinely a mess. Minecraft expects you to run almost everything through an interpolation loop. And then within that loop, it expects you to do some kind of cell-wide cache, which in a 2D sense is flat cache, with a 1D sense is cache once. And then from then on, it expects you to either use cache 2D or just cache once again. If you don't do this, you will hit some very surprising performance losses. For example, you might expect that cache 2D, if you just use it alone, it will evaluate like 256 times per chunk, like once per column. But due to the fact that noise or density functions are evaluated in a 6-nested loop, not a 3-nested loop, it will actually evaluate 48 times per column in the overworld, for example. And this just means that you are getting 50 times worse density function performance than you would intuitively expect without flat cache and interpolating and just using cache 2D. So my rule of thumb is to just stick within these. This is the framework my Mojang uses themselves. It works. It looks okay in the vast majority of circumstances. It's performant and reasonable. you try and deviate from it, just be careful. Like, it's really easy to hit a bunch of successive 10%, 20% increases of world gen performance without noticing it until you're like a couple weeks in. You're just like, why is my pack 3 times slower? So just be careful. I would try to explain like why each cache breaks, but each cache breaks in a completely different way, used differently. So it's very ambitious to explain that, and not of much use, honestly. Another thing, do not put interpolation loops inside interpolation loops. It will break everything. You will post a screenshot showing terrain so messed up I would have no idea how to make it myself. uh, yeah, so it took a while for me to figure out that every time people were doing that, they were nesting interpolations. That's iffy. Do that at your own risk. Yeah. So compilation lag is something that I talked with Gegi and will hopefully be addressed in the restructuring of the system. But as it stands, every density function is compiled once per chunk, and it's compiled in a naive way. And what that means is, every time a function is written, like referred to, is compiled again. So let's say we have a Mandelbrot set function that's implemented the naive way. Mandelbrot, if you don't know, is you have a pair of numbers, it's a complex number, but you iterate it by essentially squaring the two numbers and subtracting one from the other, and then multiplying the two numbers and multiplying that by 2, and storing them, adding a constant, and then iterating. What you need to know is that every iteration refers to the previous iteration twice. Now, in a cache system that behaves sanely, you might expect, okay, so sure, it will, if you follow the logical tree structure, that's a ton of calls, but as long as the cache works, then that's not going to be a problem, because every value is only computed once. And sure, the value is computed once, it is compiled naively. So what happens is, every chunk, your compiler is going to go, okay, we're going to go the first path, the first path, the first path, the first path, great. First path, second path, first path, second path, second path. It's going to go through every single permutation it can possibly do through your code and compile them each individually. And then most of the time discarding the results. And I've had this happen before where I've had somebody use a complex continentalness function, and they put that in the ridges function. And what happened was, the ridges function in vanilla compiled, I think, hundreds of times. So while their function was fine when it was just for continentalness, which is only compiled like 50 times less, ridges function is compiled a lot. And when they put that complex function in the ridges function, it created a very long compile time per chunk. And this is a very big problem in large-scale packs. Like, Tonic was plagued by it, and it currently contains some code that a friend and I wrote to specifically patch compiling compilation lag. And so when you're making large projects and it's just for a vanilla player base, and I will say, to my knowledge, C2ME completely fixes this. So if you use that, you should be fine. But I wouldn't rely on it. But yeah, the number one limitation on data function complexity right now is compilation lag. And the best I can say is just assume that caches are going to break once per chunk. And your code needs to not be too tangled to handle that. And part of why I needed to write a single 1,000 tree sound file for my Mandelbrot set is I had to not invoke compilation lag per iteration. And the only way I could think of to do that is pack both values into a single double, and then manipulate those two independent values within the double separately using numbers as like vector operations. It was really cursed, and I had to use like 50 absolute value functions per iteration, and it was bad. And I'm glad Gegi is going to try and fix that, because nobody should have to do that. But my advice now is to try and avoid like vertical logic, or logic that refers to previous steps instead of logic that refers to core steps. Because as long as you always refer to like your base noise functions, then compilation lag you can incur is linear. It's only when you start like layering every layer depending on the previous layer multiple times you hit the exponential case. So as long as you structure your project right, you won't hit this in my experience. It is something to keep in mind. It is something that I've seen a lot of world gen devs hit, not understand, and give up. Yeah, it's not great. So the last thing is, a lot of times you'll see your terrain and it will have these squares in it. Minecraft will have terrain that you look at, it just has these squares in it. To some extent it looks okay in Minecraft-y, but it's not 100% ideal every case. And what's going on there is, when you're using interpolation only really knows how to fix up the performance of smooth functions. I'm going over. It's okay. So interpolation can't really fix, say, an absolute value. It's not going to look sharp. It's going to have this clunky bump area smooth over. And it's just not, and it just doesn't look good. Like, it's hard to visualize hard to visualize by just saying it, but if you've ever just looked at your terrain and it just looks wrong or like full of squares or something, probably because you used one of these functions really drastically, and the interpolation is really struggling to handle it. So one fun thing you can do is you can find the quarter negative Vanilla uses as its terrain generation, and you can replace it with, say, a spline, and it will make everything look smoother. And it's really hard, especially in like screenshots, to show that. But whenever you just look at your terrain, it just looks wrong. It just looks wrong. It's because of the interpolation basis being whack. And this kind of just trust me a moment, but it really is the core of why your terrain comes out like that sometimes. And it's why I love splines so much, because splines allow you to do most of what you would see here, like absolute value, clamping, range choice, anything like that. It lets you do that smoothly. So usually use a spline to emulate a smooth version of these every time I want them, and it worked out well for me. And splines are amazing. Okay, yep. So one thing I want to get is density functions sometimes like even seemingly simple things are complex. So just try and avoid making it more complicated for yourself. Simpler approach you can find to something that could possibly work, that does work, is the best way, almost always. And more complexity is usually more bad. So always just try and find, like, what's the simplest thing that could possibly work. Try and do that. And what you'll find is that sometimes those compromises you make in your implementation, that you don't do when things 100% right, like sometimes those artifacts look good. And I've more often than not, when I've not implemented something like completely mathematically perfectly, the artifacts have given it a little bit of character and like Minecraftiness that I really appreciate. So if you're coming away with like a core mindset takeaway, it's that I've shown you a really, really complex thing on the title screen, and I want you to know that that is not the goal. That is not something you should try to do. In fact, I'd even argue that what I did there was antithetical to getting actual world gen done. Yes, it is part of the beauty. Is that the Araf? Okay. Yeah, you can do arcane magic that drives you insane. I'm just insaner. Alright. So, some things that you're gonna want to know about if you get into density functions, you do not need a deep understanding of these. Like, I will probably abuse terminology at several points. You do want a surface level understanding of vectors. So, vectors are basically just describing a direction by how much in each component, so x, y, z, changes. And you can get that by taking a noise and subtracting it from itself shifted over 1. And that will basically give you arrow as to where you can go to go up the noise. You do that in the x and z, and also y if it's 3D. So vectors are extremely useful. You're going to see it a lot in the examples I'm going to go through. The modular arithmetic. Uh, so you can get modulus by taking whatever your clamping of choices and subtract the input from the, or not clamp. You subtract the input from the rounded input. So the way I usually remember it for the older functions is you have x plus c minus x. And c is 200,000 cubed. And that's how I do it. But nowadays in modern density functions, you don't have to add and subtract a big number. You can just use the round density function that's available. So being able to do modular arithmetic lets you do one thing that's really interesting, and it lets you multiply in a way that scrambles the numbers instead of grouping them together. Because normally, like when you multiply by 2, the only results you're going to get are even numbers. But if you multiply by 2, and then if you're greater than 7, subtract 7, then you'll notice that you just kind of map everything to something else. That's going to come in really handy at some point. And that's something that you may not need, but when you need it, you're gonna love the fact that it's something you can call upon. And lastly, if you're getting advanced, you should probably just look into the noise internals for your versions. Not gonna promise they're not gonna change. But uh generally speaking, what Minecraft uses is every octave of a noise. Is actually 2 octaves. Normal octave and the shadow octave. Shadow octave is offset 337 divided by 331, the scale of the normal octave. So, if you're ever wondering why you can't just use a single octave of a noise and start seeing, like, Purwin artifacts, it's because there's a shadow octave there. And, uh, that is knowledge that will either never come up or come up all the time, depending on how you like to do density functions, but it's something to be cognizant of. Alright, so we're gonna go through some examples. Uh, real quick. So, one thing that I use oh, no, I swear every time I look away, it doesn't click. Alright, so one way you can use the Shadow Octave knowledge is want to make caves that were big open areas and that narrow and widen into caverns that connect each other into large expanses in a more organic way. The way I kind of liked cheese, noodle, and spaghetti caves, wanted something that was all of them. And so what I settled upon is the way Purwin noise works is it creates a set of points in the grid. And for each of those points, it has a very strong slope attached to it. And it interpolates between those vector points. So what this creates is discrete points where there's very high slope. And then in between them, there's flat out, not high slope areas. And when you have 2 octaves, one normal and one shadow, then you get these grids converging and diverging. And so one really simple way that you can get some really good looking caves is you take your noise and you take the magnitude of the gradient, which is another way to say how deep the slope is. And the way you do that is you just square you're subtracting the noise from its shift itself for each direction and add them together. Then compare that with a constant. And these caves end up looking really nice. I probably will polish and publish them so everybody interested can enjoy them. But this is my favorite cave technique every time I'm doing like a dimension and I need caves and I don't want to do vanilla caves. I just swap these down. It's a single file and they look great. And they use the internals of the noise system and how it's implemented to its fullest. So dunes, dunes are something interesting. Like if you can make dunes and slot them in, then that brings a lot of life to a project. Tectonic dunes are from me. Uh, so what I do is I have a dune noise, and it's going to be folded like absolute value, just like rivers are, or just like mountain peaks are. And then I'm going to have a wind direction whenever uh the dune aligns with the wind direction. Then I let it be full height. Whenever it disaligns from the wind direction, I let it drop down to base value. And so these do these and so you get this pretty cool effect, especially with the specific style interpreted. You get your softened slip face, I think it is, where one side's steeper than the other along the wind. And the way this was done is I had two separate components, one that represented how face on the noise was to the wind, and one that represented how parallel the ridge of the noise was to the wind. And by carefully managing those, I get this. And for a long time, this used to be like my favorite world to just like sit and AFK in. And like whenever I got bored, I just teleport a couple $100 away and set up a new AFK platform. It's really relaxing and thoughtful. But yeah, dunes are a really simple way to start messing around with the vectors that you can use in World. So yeah, one thing I like to do is rivers, and one thing I don't like is when my rivers are little tiny onion rings that don't connect to anything. Like it's not a pet peeve everybody has, but it sure is a pet peeve I have. So one thing you can do is you can actually base the terrain on the ridge's noise, such that you have again a wind vector, and whenever the river starts flowing the same way as the wind vector, then you've just put ocean there. You get this really organic and beautiful effect where the rivers will always flow to an ocean because they're closed loops, they have to at some point align with the wind vector. So uh so if you're just trying to like make rivers that always go to the ocean, it's going to look like really hard. Like, a lot of people would just straight up tell you that's impossible or hugely impractical in vanilla. Yeah. Yeah, that's part of why I'm giving these examples. I want to give everybody a few new ways about thinking about things. So you get some really neat looking effects, and by messing with the wind noise, you can change the terrain shapes. It's, one the main compromise is always going to be these examples are optimized for simplicity. Like they're not going to have the most intricate, explicit handling of edge cases, and you're not going to get fine control. But I think it's best to try and lay down what happens mathematically and kind of let the system take the wheel from there and see what happens. And sometimes like this, I think the results end up looking pretty unique. And nice. Okay, yep. So I'm going to do something. This is what I stayed up 8 hours doing because I really wanted to show something of this complexity off. We're gonna do some mazes. And so mazes are something that's going to seem like really rough to do because they need some kind of global structure. You need to like make sure they have a path. And so that sounds really intimidating, but we're going to take it piece by piece. So first, we're going to have our walls in both directions, and the core idea of our approach is every cell is going to randomly pick a wall, or one of these planes of walls to pick from. So on the cells where the dark lines intersect, that will always be a wall, and the cells where the light lines intersect, that will always be a room. Whenever there's both, it will randomly decide between a room and a wall. Now, that's not enough to get cool maze structures, but that is enough to build a framework off of. That is going to be the core shape of our mazes. So, here, what we're going to do is every cell is going to refer to its neighbors, and it's going to pick the higher one according to a base maze. And it's going to use that as the seed for the random value. Now, what this means is that lower value cells are going to look at higher value cells, and the higher value cells are going to decide how they connect. What this happens is you get higher level cells flowing down to the lower level cells. And as long as your gradient always has two distinct ways to go up, this makes mazes that don't have dead ends or anything. Now, they look a little boring for now. But we'll get back to that. Yes, as you can see, the maze is actually flowing up along a noise gradient. Like I said. So the what's top left for you? Yeah, top left corner is higher than the bottom right. So it's going to flow down from top left to bottom right. And ooh, a laser pointer. Item. Ooh. Oh, cool. Okay, so this is the highest point. This is the lowest point, and it flows down from highest to lowest. There's something else. Ooh. Oh. Okay. Something else I wanted to do is spirals. So spirals are something I haven't thought about, but I was like one day I was just like, oh, I want spirals. So all we do is we use the height of the noise as an angle, and then we take the direction of the slope, and we see how aligned it is to that angle. And we use that to modulate the bass noise. And so we get these cool spiral shapes, and there's different ways to approach that. I will find a way, or I will polish and uh post the data packs for all the visuals I use. Uh I don't know, maybe we could do something with Deep Sway. Maybe I have reason to actually put something on my website for one, and we can make the spirals go around. So yeah, the spirals are something I wanted to do. The reason I wanted to do spirals is if you remember the mazes, they go from lower to upper, but it's kind of like really predictable when it's just a noise, like which direction is going to be upper. So like I wanted a noise where like going up isn't necessarily intuitive which way you're automatically going to want to go up. So when we nest these, we get these really intricate maze shapes. So yeah, this is using the spiral as the height map that the maze feeds into. And so we do get a bit of dead ends because uh, because the maze algorithm The maze algorithm I use is shift click, I think. Yeah, the maze algorithm I use isn't absolutely perfect at preventing them. If you want a good place to you want a good place to start improving this, the first thing to do is when a cell has only one way to go up, it picks that instead of randomly failing. And that will fix basically all of these artifacts you see. But I just wanted something simple to show some more complicated techniques and how you can compose different ideas into one to get more interesting effects. And that's kind of the power of density functions. Okay, so lastly, I want to get into region. I mentioned before how you can do fine soft surface for regions, but this is my preferred method. So every distinct color blue on this picture is a region. And the way I'm doing it is I'm multiplying numbers and then using the modulo a prime number. So like I said earlier. So what this does is I'm using 3 noises here. And this creates these really chaotic regions that I love the look of. And what's interesting is that because this is using discrete noises that we multiply together, if we take the fractional parts and we multiply them together, we get a distance approximation from how far we are from the edge of the region. And so this gets a really nice effect where you can use sorry, I was being gifted spam mail. Uh so okay. So we have yeah, so as you can see, like our mountain type biomes are being placed on mountain terrain, and the like jungle or plains type biomes are based on plains. These swamps are partially underground, and it's a really cool effect. And I I use this for an island data pack, and I think it's one of the best applications of region noise, just like period, because it's really nice. Like I'm using an LOD mod to be able to see this, but yeah. Uh, Whenever I have an ocean and I have free time and I have the authority to fill the ocean, I fill the ocean with these because a little archipelago of like unique curated experiences of biomes is just the absolute best thing ever, and you can't convince me otherwise. Yeah. So here is where I am going to let everybody provide their questions. Any problems you've been dealing with density functions, if you've had any. Uh, I'll be looking in chat. So, uh, if anybody has any questions or like wants any advice, I'm going to be open for the next moment.
Thank you so much for the presentation. I've DM'd you a doc. I'll be collecting questions as well because we have our YouTube live stream and our Discord stage.
Okay. So. How reusable? It's actually very reusable. Like every time I start a project, I judiciously steal from my old stuff because I did not spend 8 hours staying up on one project just to and like making it really configurable and usable for me. Just using one. So, how do I recommend? It's a bit cliche, but try and read and understand the wiki as best you can. And then what I recommend is trying to recreate an overworld from density functions from scratch. Not the overworld, you don't have to do it as good as Mojang does, but try and solve the same problems Mojang does. So for example, try and make continents in an ocean. Try and make mountain ridges. Just go through everything and try and figure it out yourself because that's going to give you the intuition, one, for problem solving, and two, for understanding how vanilla does, how and why vanilla does the things vanilla does. And that is going to be your best onboarding. I don't know any other way to to onboard that's better than just trying to make something. And the best part is if you get stuck, you can look at how vanilla does and try and understand how they do it and implement it yourself. So, alright, let me take the docs. Okay. Yeah. Practice makes perfect. In this case, I think it's also like focusing on your weaknesses immediately will help you a lot because just being comfortable making stuff instead of modifying stuff that you don't understand is going to be the biggest help you could ask for. What resources other than Miso? I usually use VS Code's autofilling extension. And whenever it worked for me, I use the data pack previewer extension. It was kind of working for me. I suspect it was something with the 26.3 changes. So I had to use the viewer tonight. But definitely a VS Code. And definitely like Spy Class and the extensions you're used to from the other panels telling you about them. Aside from that, pick up a scripting language if you're going to get serious. There's a Beat plugin if you like Python called Gaia Beat. I personally use JavaScript because it's really easy to generate JSON in JavaScript, and I know JavaScript because I was forced to learn it. Yeah, you can use TypeScript too. I'm not gonna kill you for putting a type annotation on. Gaia is still up to date. I don't think like any of the framework is going to be up to date when you 6.3 releases, but all right. What specific math knowledge? Okay, so you are going to want high school level, and what I mean by that is American Standard. So you're going to want to know how to like roughly what a polynomial is, what a line is, how to find the like y and x intercepts of a line, that kind of general knowledge. And then you're gonna want a scattering of being able to read the Wikipedia for things and get the general gist. And that's all you really need. Like I technically like this every time I mention vectors and gradients, that's gonna be like deep into calculus. But I'm gonna be honest, this is a I read the Wikipedia page and got the vibe kind of understanding needed. You don't need to be deep into calculus, you don't need to be able to like manually solve integrals and derivatives or anything. In my experience. So as long as you're like not struggling in high school math, you should be fine. If you are, then I uh recommend looking into how vanilla does things and uh trying to learn techniques that aren't as math heavy. So like you don't need vectors or slopes or anything to do most basic world-gen tasks. Vanilla doesn't really use them at all. So just stick in your comfort zone. You don't need too much math as long as you a general understanding of a topic your own independently. You should be able to do it on the fly. Yeah, Beat mentioned. Yeah, thank you for Beat. All right, what's this? All right, so when I start using splines, values and spline. Okay, so splines inside spline. Uh, one thing you can do is first of all, if you find yourself losing control of it, one thing you can try and do is you can try folding the spline into one thing and then combining it separately. A lot of like overworld remakes I've seen do that, where they have instead of nesting a continental nest erosion and rigid spline, they have them separately and then they have a combining function. So if you're ever feeling overwhelmed by how deep spline is, you can break it into component parts. Otherwise, I just say uh don't make any changes that are too drastic and try and make sure that you're covering the domain evenly. The domain is like the input ranges and how close together they tend to be. As long as you do that, like Vanilla does a pretty good domain covering. It's offset in similar splines. So as long as you for your multi-layer splines, you keep the points at appropriate points. Just try and make sure that even spread over the domain is the big thing, and don't have too big jumps or like really weird derivatives. when layering splines, it's usually best to keep derivatives 1. It's the derivative 0 unless you need them to be something else. Yeah. Um, how many panels have Beat been mentioned now? I don't know. Beat's cool. I don't even like Python. I like using Beat. When working with them, what do you think you could be improved? Right now, I've spoken with Judgy about this. Right now, removing the compilation lag is possible. I've done it. It's about like 20 lines of code. That would be huge. Uh, the other huge thing would be uh, some way to do modulus without incurring compilation lag would be nice. Now, obviously, compilation lag doesn't exist, and that's a moot point. But like a cleaner way to do modulus would be nice. I actually think that like as far as the system stands, we're actually in a really healthy spot. Like Gegi is giving us plenty of toys to mess with, and a lot of things that were a huge pain. Like, do you like I like having to wrap into the Farlands patch 25 times to cover a world is really annoying. Typing X into a gradient field is not. Like, thank you, Gegi. So what could be improved? As far as tooling, I think tooling is either like I think tooling needs to focus more on quick iteration. Uh being able to type something in and then immediately seeing on the screen if it works or not with like no overhead is why Miso's editor is so nice for density functions. WorldGen Dev Tools is also a godsend, using Beat to broadcast your data pack to the world folder. All of those work, but just being able if you're writing a lot of people write like a domain specific language for density function. Uh if you do that, you should try and make it so when I write the domain specific language, it updates the preview. Like if you combine those two, then you just have like a killer product. If you make it a web app so I can do it from whenever, then like it is the best thing ever. That's why Miso is so good, even though this occasionally has its mishaps where it like overrides files and stuff. Oh yeah. Yeah, the one annoying thing about Minecraft's data pack tooling being so Python based is it's really annoying to try and build it for the web. I've tried to do it, but it was beyond me. I'm not great at web assembly. All right, what would I recommend messing around with first? Yeah, again, that's gonna be try and make an overworld. Like that is just going to be the fastest way you're gonna get experience. Uh, as long as you have the basic ideas and like you can like ask a great place to go is Stardust Labs WorldGen Dev. I check there compulsively if you have issues, like you want to know how to turn a noise into a height map. I will be like, okay, you just add it with a Wycombe gradient. Yeah. Yes, the Stardust Labs Discord server WorldGen Dev channel is an absolute godsend. It has been consistently one of the best places for data pack WorldGen for going on 4 years now, maybe more. Yeah, it is absolutely great. Uh, you, a lot of really intelligent people, not even including me, a lot of really intelligent people are there watching it, ready to help if there's something that they can be of use for. But yeah, for starting as a beginner, I do recommend the overworld homework for this day. I actually do have a full list I've been polishing up that I gave out once to one person, and I've had like a lot of people find it and come tell me how useful it is. So I may polish that and put that out as an appendix. Yeah, I do think that we're making an overworld is going to be the fastest way to start getting a grasp of things and getting the sense of satisfaction from having made something. Uh, it's really up to how you learn. Like some people will just sit there for a couple years and then just start doing it and just be amazing. Some people it doesn't really help at all. It's on you. How you learn. All right, noise iceberg frozen getting Okay. Right. What do those use? I think those are the maximum of two noises, not multiplying. I think that's where you're being stuck up on. Uh, yeah, it's the max of one noise that's absolute value, and the max and a noise that's not absolute value. I think there's a minimum. I haven't read the code in a while. Uh, I'm gonna link ncsrc.dev. That site will let you look at the source code of the game. Whenever you have a question like this, just open up the source code and try and take a look and see what's happening. And thank you. All right, what are some terrains? Oh, what they're harder than. Okay, this is getting into one thing. So I have an open problem in density functions. They call it the splotch problem. And so it's without using x or z coordinates directly. Create splotches of a fixed minimum and maximum size around the world. That's it. So a splotch is just like you can think of it an island that has a minimum and maximum radius. That's the best way to check that. So you have two options. If you like Java, then you can look at the data generation code Mojang does. Mojang ships that in their jar. I'm pretty sure you can find it on MC SRC dev. If you like JSON and understand it, you can look at the default data files. You can either unzip Minecraft or find it on MC Meta's GitHub repo. You can also find scattered around the internet when people recreate the vanilla density functions in their own domain-specific languages. Like, there's a Rust project called Density Function Lang, I think. That one has a reconstruction of all vanilla density functions in a more readable format. And look for those kind of projects, because what they like to do is recreate vanilla with them to test how expressive they are. So you kind of have your, like, three paths. Whichever works best for you. Whichever you can read, it comes down to. Just, check one of those. And from there it's a bit hard to like describe how you have the soft skill of deciphering somebody else's density functions, but I find it helpful to try and write a summary of what I think should happen, what is actually happening, any major differences, and why those differences might be there. That is a pretty good framework for comprehending them. Okay, so yeah. uh Noise icebergs don't use an exposed density function, but they do use logic you should be able to recreate with them. Yeah. Um. Okay, I should check in the Google Docs for open questions. All right, overhangs and ledges. All right. So the easiest way to do overhang is actually to modulate the Y-claimed gradient you add to the noise, not the noise itself. And the reason you might want to do that is that lets you still use a 2D height map, so you get all the performance benefits of your 2D height map, but by changing what Y values are equivalent to what positions and making it go like back down as you go up, uh, you can get overhangs, and those often look pretty good. That's like the easiest way if you're like trying to go for like some carved out caverns aesthetic. Or like some mountain plateaus that overhang, like that's gonna be your best way. Uh, if you're just trying to make the overworld like cooler, uh, just add some noise. Uh, Vanilla uses something called base or uh old blended noise. What it is actually just one noise that warps between two other noises. Uh, and you can do something like that, or you could just use old blended noise directly and just add it to the world where it's appropriate. And the noise is often better than you will ever be at like intentionally adding variation because that's its job. as long as you pick a shape of noise that looks pretty good for your use case, then you should get the wedges you want. Like, I think Beta has some really nice wedges, my opinion, and that's why data packs like Cascades are appealing to me, is because they up the factor. And that's really mostly all they do is just up factor. And they end up looking appealing to me. But yeah, Cascades is great. If you want a good example of how you can make minor changes and still have it turn out with a good result, Cascades is a really good case study at just how a few knowledgeable tweaks completely changes the feel of terrain. Okay, so yeah, let me make sure I covered everything in that question. Different. Yeah. So carvers, personally I never use carvers. They are weirdly unperformant. Like, as coming from a density function user, that's saying something. Like, they are weirdly bad in performance. They're limited. I just don't use carvers, really. If I'm just being honest, like, I would rather tear open my own ravines. I would rather make my own caves than try and use the carver system. Especially now that they removed the ability for debug filling. In latest snapshot, so you can't even use them to like fill with different materials like you used to be able to do. But we also got custom ore veins now, so it evens out. I don't use carvers just at all. Like, I've never done the analysis and considered them worth it personally. By gradient, 3D noise. I think I covered most of what I have to say. Yeah, just modulating the 3D noise is the easiest way you can have to do overhang. Yes, that one, hybrid beta. As far as I know, that's just a tweak to a few splines, and it looks great. Yeah, I think that's that Google Doc question covered. Okay.
Cool. I think we've reached the hour. Excuse me. We started a little bit late, so it took us a second to get the talk going. But
Yeah.
thanks everyone for joining us. Any last words you want to add in, Uni?
Yeah, I just want to say that I just want to say that in general, density functions are I used to love them because it was so hard to do anything that like doing basic tasks like circle was really satisfying, but I've come to love them because they really capture the spirit of creativity. There's nothing quite like just investigating, like, what happens if I use a noise in this way and saying a cool thing, like, oh, this makes a spiral. What can I use a spiral for? And then you're like, oh, I have this maze idea I made earlier. What if I put the spiral into the maze? And like, you get this, ooh, this maze looks very fun to explore. Like, that, the flow of density functions is about like getting the most you can out of simple ideas and composing them. It is not about like extremely complicated stuff. At least in my opinion. And you will get a lot more fun just like composing different simple things and investigating new simple things. And just in general, less is going to be more in most cases. Like, I've had a friend, they're trying to remove, they had an island data pack, and they're trying to remove rivers from it. And what they did is they sat there for 4 hours editing the splines to remove rivers. Then I sent them a data pack. I think it was 11 lines long in terms of code. What it was is it just was a spline on the ridges noise. It just snipped out the range of the ridges where rivers would generate. So really, if you spend time overthinking how you're gonna do it, it can like save hours. So just pick your approaches carefully. Simplicity and elegance is going to be your friend a lot of times. And especially now as the system is getting more friendly to use, just don't stress yourself out with anything too crazy in of itself. That's about it.
Cool.
Thank you.
Well, thanks so much for presenting intermediate to advanced density functions. For the rest of the docket on Summit, in about an hour and a half roughly, we'll have How to Port Your Packs Faster by Creeper. I also want to shout out an event that we'll be posting on the calendar very shortly about a World Gen talk. Oh yeah, it is. There's going to be a World Gen discussion, kind of Q&A / fireside styled on Friday, about like 4:30 PST. But it'll be, I guess, 8:30 EST and other times. We'll get that on our calendar very shortly, and there'll be an announcement about it as well.
I'm gonna try and make it there as well. If you have any questions you come up with in the VOD for anybody watching this.
Yes, for sure. Other than that, we'll go ahead and close off the event. We'll see you at the main chart and potentially at the next panel. Thanks, everyone.